Welcome to another video in the Edge AI Masterclass, where we are exploring the different type of sensors. In this video, we will look at an often overlooked but super interesting device, namely the gas sensor. So let's get started. A gas sensor is a device that detects the presence of gases in an enclosed space or area, often as part of a safety system. How does it work? Well, one common type of gas sensor is the heated metal oxide sensor. This type of sensor operates by heating a metal oxide film that results in the release of electrons. In a regular non-gas atmosphere, these electrons react with oxygen, leaving little to no free electrons. But in the presence of a gas, and thus in the absence of oxygen, more free electrons are available, resulting in a higher flow of current, which can be measured and converted to an output signal. When choosing a gas sensor, it's vital to pay attention to certain specifications. These include the type of sensor, which would depend upon the gas or gases to be measured, measurement range, and the response time. Most gas sensors come with an MQ code. For instance, MQ2 are used for detecting LNG and smoke, MQ3 for alcohol or ethanol, and MQ7 for carbon monoxide. By the way, if you are wondering about the mesh on the sensor, that is added to the sensor to prevent dust from entering and to prevent inflammable gases from catching fire. Real-life applications for the gas sensor are vast and varied. In manufacturing environments, it is used for monitoring chemical emissions for safety and compliance. In HVA systems, they ensure air quality by continuously monitoring and selectively engaging air purifier systems when the quality drops below a certain threshold. They are also used actively by firefighters and the emergency response teams during fires to detect gases, strategize, and create evacuation plans. In homes, gas and smoke sensors are used to intimate the residents and the fire department of a leak or a smoke. In fact, since gas sensors have relatively higher response times, sometimes in seconds or minutes, a good place to put them, at least in the kitchen, would be to put them right at the stove level. This small adjustment could prevent many more fires. Coming back, in cars, they could be used to detect carbon monoxide and other toxic gases and automatically roll down the windows and cut down the engine. Since governments around the world are spending a mini fortune to build smart cities these days, let's also look at some smart city applications. In wastewater pipes, gas sensors could be used to automatically detect high levels of toxic and inflammable gases, and automatically open additional release valves to disperse these gases to the upper air. Similarly, in confined spaces, like underground shelters, malls, metro stations, and even in mines, gas sensors could be used to detect high levels of toxic gases, so that corrective actions like opening of additional air shafts and turning on of additional air purification systems could be performed. Or the emergency response teams could be automatically notified and an evacuation of the space could be initiated, depending upon the severity of the situation. And finally, to protect city residents from the toxic air from forest and farm fires, air purification towers could automatically be turned on using signals received from gas and particle sensors. And that is all for this video and this mini-series on the different types of sensors. Hope you enjoyed this series. Do let us know in the Q&A section if you did. Also, let us know which idea did you like best and which sensor has the most varied and interesting applications. Finally, let us know some of your Edge ML application ideas, which using one or more sensors and machine learning solve a customer pain point. In the next video, we will look at the things to consider when selecting an edge device for an application. See you there.